Topic 4, energy transfers. So what is energy? Energy is defined as the ability to do work. Energy cannot be created or destroyed, but can be converted from one form to another. Electrical energy can be changed into light, heat, or movement like kinetic energy. The most common forms of energy are chemical, electrical, mechanical, thermal, sound, and light. Chemical energy is potential or stored energy in chemicals released when they react. This is like a battery. A chemical reaction is what creates the voltage in a battery. Electrical energy is the energy of charged particles. It's the energy that comes from an electrical source, so like the plugs in our house. Mechanical energy is energy possessed by an object because of its motion or potential to move, like a generator. Thermal is heat energy, so the kinetic energy of a substance, maybe a heater or a toaster. Sound energy is any noise we hear is a sound wave, which carries energy itself. So sound energy could be our headphones or maybe a microphone. Light, like sound, is actually a wave that we're able to see. So a light bulb itself, a flashlight, any sort of light that we can see in this world. Electrical devices convert electrical energy into some other form of energy, or maybe vice versa. So a toaster, our first example here was we input electricity to a light bulb, and the light bulb converts that electricity into light, but it also converts it into heat. Don't forget that there are some alternatives that we may not necessarily consider. A toaster, again, uses electricity to convert it into heat. A radio uses electricity to make sound. A blender uses electricity to produce mechanical energy. Don't forget, a blender also makes sound energy too. It might even make some heat. Now, the last one is a microphone. A microphone uses sound energy and converts it into electrical energy, which is sent to a speaker, and that turns it back into a louder sound energy. So a microphone is just one piece in this list of electrical devices, but its conversion is a little bit opposite here. Electricity and heat. Most electrical devices are designed to produce heat. They have a resistor or a variable resistor in them. These resistors transfer energy from electrical to heat energy. So for instance, a toaster, a hair dryer, our clothes dryers in our house, curling irons, stoves, etc. A thermocouple is an electrical device that converts thermal or heat energy into electrical energy. So it uses two different metals that are joined together that conduct heat at slightly different rates. So we have wire A and wire B, different types of wire, and they conduct heat at different rates. When heated at their junction here, where the two wires meet, the difference in their conduction results in electricity flowing from one metal to the other. It's used as a safety device in your furnace and hot water heater. They only produce a very small amount of current, so noting that we're looking at millivolts here. They're useful for measuring temperatures in areas that are difficult to access or too hot for regular thermometers. Again, these different wires conduct at different rates. The cold junction is literally just where they meet a regular wire or like room temperature. Depending on which wire is connected where, we'll get a current flowing through this circuit. There is a video, and I've linked it below on our course website in the extra lesson video links or whatever I've called it, on thermocouples. And I thought this guy did a really good job explaining it and actually shows it in real life because we're not doing labs here. A thermoelectric generator is a device that's based on the idea of a thermocouple that can be used on a commercial scale to convert and heat energy into electricity. So a thermocouple is fairly small, but we can use this generator on a bigger scale. So it uses two different metals and a heat source as well. And several thermocouples connected in series is called a thermopile. So we're using those two different metals and we're using a thermocouple, but we're connecting lots of them together. Thermopiles are extremely reliable. They're very low maintenance and are often used in remote locations for power generation and heat generation. Electricity to motion. The piezoelectric effect produces sound by converting electricity into motion or vibrations. So when a piezoelectric crystal, like quartz or even sugar crystals, is connected to a potential difference, so a voltage source, the crystal expands or contracts ever so slightly. Material touching this crystal experiences pressure or this pressure change, so this expansion and contraction, and it creates sound waves or vibrations. Again, a really great video on the piezoelectric effect to help explain this because we can't see it on our level. We can also convert motion to electricity. A barbecue lighter uses the piezoelectric effect in reverse. When a piezoelectric crystal is squeezed or pulled, a potential difference is built up on the opposite sides of that crystal. Conductors that are attached to the crystal take this into a circuit, producing electrical energy, or in the case of a lighter, a spark. The piezoelectric devices could include greeting cards. So when you open a card and it turns into a sound, we're using the piezoelectric effect there. Barbecue lighters, a quartz watch. There's multiple different things in life that use this that we would have never considered. Electricity to light. Of course, we know this one. 3 different types of light bulbs: an incandescent, which was our very first kind of light bulb. A thin filament, usually tungsten, heats up and produces light through this circuit. So you can see that the tungsten connects the circuit here. Most incandescent light bulbs are very inefficient. Only 5% of the energy actually goes into light. The other 95% is released as heat. Compact fluorescents, or CFLs, are more efficient and they last longer than incandescents, so about 25% more efficient. A fluorescent light, the gas is excited with an electric current, and that excited gas produces light. The last one looking here is an LED, a light emitting diode. They are so much more efficient than an incandescent light bulb, and they use a very, very small amount of current. So they are a little bit more expensive to install in your house, but the life expectancy of them is very long in comparison to other light bulbs, and the cost savings in terms of the current that they draw in a circuit and what you would pay for that on your electric bill is a cost savings. We can use light to electricity as well. So we can produce electricity directly from the sun by using a photovoltaic cell. A photovoltaic cell, or a solar cell, is made up of some sort of semi-conducting material like silicone. Silicon, sorry. When light is present, this semiconductor or silicon breaks electrons loose and absorbs some. Metal contacts at the top and the bottom of the cell draw the electrons away, and the current can be used to power devices. So when light strikes, electrons break loose, they get transferred to something else, and that transfer starts a current. A number of photovoltaic cells can be combined together to make a photovoltaic array. That's what we would see when we see a solar panel. Satellites in the International Space Station are powered with photovoltaic arrays, and we're, of course, looking at this as a power source more and more in society. A great video that shows how a photovoltaic cell, that's very hard to say, works. Again, where it strikes, where light strikes something and it releases electrons, and those electrons can be harnessed within our circuit. Certain animals actually, like the electric eel, can produce an electric shock to kill or stun their prey. They have a special organ that contains different muscle cells called electroplaques. Each cell produces a very small amount of electricity, but when all the cells work together, a large amount of electricity is produced, and they can help the eel to survive against these predators. This type of electricity is like static electricity, which builds up and then discharges when the eel strikes. Some practice. Don't forget to complete the learning guide for this topic. There is some extra practice in your textbook as well if you'd like to take a look at it.